We need to record you for posterity.
Okay, before we get started, let me just reintroduce the team here. So I'm Alex, Joe, and Thomas and Brian. So that's Thomas with his hand, and Brian, wait. We're three mechanical engineering students from the ME department. I actually graduated in December 2005. And now I work on campus at the Center for Environmental Design Research, working on California Energy Commission funded research projects. Okay, so let me just start by giving you something to frame our project and the rest of the presentation. Some of you may be familiar with this. This is a picture of the hydrological cycle. And in our case, we're showing how water connects society, the environment, and agriculture. Water has been pretty much virtualized to most people, meaning you turn a knob and it comes out of a hole in the wall and it goes back into a hole in the wall. But the reality of the situation is that we get our water from somewhere, which is generally the earth. And when we use it, it goes back somewhere. And so you can see the water flows between the society and the environment. Same way with agriculture. Irrigation for agriculture comes from water sources and runs back off into the environment. And this is really important to understand because water isn't just out there on its own. In addition to transporting nutrients and salts, it also transports chemical pollutants between all three of these sectors. So water connects everything. It's important for our state to take this discussion because California is really stressing its freshwater supplies. And even though in a wet year like this we think, oh, we're not going to have any problems with water, we do. We use 46 million acre-feet of freshwater annually. To sort of give you a sense of reference, that's about 180,000 rose bowls annually that's just used. And for our freshwater, we have two major sources, one of which is the Colorado River. And for the last few years, we've actually been exceeding our budget on usage of the Colorado River by 20%. We know that populations are on the rise, and we know that other states aren't too happy about what we're doing about it. As far as the Sacramento-San Joaquin Delta, that source of water has heavily been irrigated. And pictured here is the Freant Dam near Fresno, which diverts actually about 95% of the water used here to irrigation. And as a result, you can see the San Joaquin River. This is at Highway 152 heading to Los Baños. It's not much of a river anymore. And generally every year there's about 100 miles of river which is just completely dry. And so we can see the environmental impact. And so it's taken us all this time to see it, but after 60 years, for example, the U.S. Bureau of Reclamation is actually going to reopen the San Joaquin between Fresno and Merced. That's going to take water away from one of the state's most highest producing agricultural regions. And 80% of the state's water is consumed in agriculture. So anything that we can do to reduce the water use in agriculture is going to help all of us. We also know, after seeing the impacts of agriculture to the environment, that our largest industry is not sustainable. Agriculture in California is $32 billion of our state's economy directly accounted for. And it trickles down and creates a huge amount of other economies. And also, it provides 13% of the nation's food supply. There's a lot of stuff that grows here in California that just can't get anywhere else in the country. But it's generally been characterized by industrialized agriculture, which has been disproportionately focused on production and yield, and marked by use of chemicals and pesticides and over-irrigated. And these practices have had huge environmental impacts, such as creating too much salt in the soil and making unusable land, or transporting fertilizers into the water supply and other chemicals that just shouldn't be there. I mean, and to give an example of what happens when you focus too much on production and yield, let's be reminded about the Watsonville situation with the strawberries, and that was a long battle to resolve that. So the problem is, generally, that these agricultural methods are dominated by heuristics, and there's no real source of monitoring tools out in farms to get feedback on what's actually going on with the weather, what's going on with the plants, what's going on with the results. And so this sort of narrow-minded focus on use of chemicals and growing more and more and more can't account for these environmental impacts. So with monitoring, we say that you can optimize irrigation and you can reduce water use. And with that, you'll reduce all the environmental impacts that have been a result of agriculture. And so our solution consists of information technology in 3 levels. The first level is we want to put sensors out in the field. Everyone at Berkeley talks about wireless sensor networks. Here's another application. Let's monitor information. Sensors are really cheap. And let's get information about how the weather changes. All this stuff can be used not only to help the farmers plan their crops, but manage irrigation. And the biggest variable there is evapotranspiration. If we can measure that and how it varies in the field, we can manage irrigation. All that data gets collected to an interface at the farm, which the farmer, we have all this information, and it becomes transformed through a user interface and various models to help the farmers for harvest planning and applying various chemicals to reduce usage here, and then again, optimize irrigation. What we want to do is collect it globally in a database, and that will help stakeholders such as the government and commercially it can provide insurance statistics, new models for analytical analysis of agriculture, and then within the state it can help with things like water rights. That's going to be a big fight going forward. So finally, just to conclude where we are right now, the 3 of us have been working for the last 1.5 years just building prototypes, and our project's sort of been snowballing. We think, oh, let's build this one thing and talk to some people in Davis and see what they think about it. Next thing you know, we're wrapped up in people talking about UC Discovery grants and industry calling us saying, hey, where can I get this in my vineyard? So this is a big deal. We're going to start studying in vineyards. We're going to put some prototypes out this summer, work with UC Davis to learn more about physiology and the farming, so forth. Continue seeking government and nonprofit support for development. And eventually, after everyone graduates, we'll think about commercialization. And then here's our website. Feel free to take a look there, and we'll be around if you have any other questions. I can take a question. Do I have time for questions now?
Maybe like one or 2 questions.
Okay.
So, this is actually just a comment. You know, there was Caterpillar came out to visit us at CITRIS last year, and they have a business case for using this to grow tomatoes in Spain. They want to customize, so they want to work on vegetables first rather than crops like rice and wheat, because greater profits to be made on vegetables first. So one thing that we can do, CITRIS can do for you is, Gary Baldwin is our executive director. I think that we've been waiting for somebody to go pay a return visit to these guys. They'd be very interested in your scheme.
It's good services.
John, sorry, Caterpillar, John Deere.
Okay.
Thank you, Travis. He's just talking about John Deere. And what was the name of the Spanish family? Do you know?
Oh, God.
So Travis is your man.
Okay.
He can better than
do you happen to know where they're based at?
in Illinois, in what's the center? No, it's not Peoria, but pretty close. It's either Centralia or Peoria. It's center of Illinois.
Okay.
Have you talked to the people in the Intel Research Lab that's been working on?
Yeah, I know Intel did a project a few years ago up in British Columbia, monitoring the vineyard. I think the problem is a lot of these projects have been focused on, hey, let's put a network out there and see what kind of data we can collect.
Right.
How good can we get the network working?
Right.
And we're flipping it up and saying, hey, let's look at it from top down.
Yeah. Great.
Okay?
Great. Yeah, this is a microphone.